slides from Intel. So Intel runs a research lab and they also do some teaching about mobile networks, wireless networks. So I'm borrowing all those slides from Intel lab. So the topic, and probably this will be the last topic that we'll cover in this course. It's about IP routing. So we'll go in detail about IP routing for mobile network, and then we'll introduce what is MANET routing algorithms. So far, what we have seen is there is one base station and all the nodes around the base stations are mobile. So that is one way. Mostly all the Wi-Fi access point, GSM, CDMA network, there is one single base station and everybody is around. And that is the most simple case of routing. There cannot be anything simpler than that. Because the node, even if it is mobile, it will always talk to one base station. Okay. Now, the second case, so this, let's say the simplest case is when there is one static phase and mobile. Okay. So this is one simple case. Now a node can be mobile within that area or the range of that base station. Okay. What would be the second state? So if I call this number 0, what will be number 1? How can you make it complex? Moving base station, or there could be something still simpler than that, but complex than this.
More than one base station, like one
Right.
Right.
Right. So I'm saying M static bases and N mobiles. Right. Every base station is unique and different, independent, and then there are mobile nodes and they go from one base to another base. Now let's come to the next complex. So this is what we have looked at already and how routing is done. Right. Now what will be the next step? How can we make it more complex? Dynamic base station, yes, we get it. So there is no separation between base and mobiles, right? So even the base stations are mobile, and as soon as they become mobile, there is no difference between mobile and base station, right? So far we are calling all these bases because they are static, right? As soon as we go into a model where everybody is mobile, so M mobiles, then basically there is no base station. Everybody is mobile, and then you want to send the packet. And this is the hardest you can be.
Second is ad hoc network.
Second is still not ad hoc, because something is static.
No.
This one, yes. So number 2 is ad hoc. Right. So this is totally ad hoc. There is no infrastructure. Right. The reason for more infrastructure is coming from the static basis. There is no infrastructure, nothing. Everybody is mobile. And it's totally ad hoc. Whatever is the current plane, you see the situation and you design. And that is what is mobile ad hoc network. Right? So the MANET word, the E is usually silent when you pronounce it. So this stands for mobile ad hoc networks. It's a very common word. So we start looking into how to solve problems. We haven't yet looked at this. So where does mobile IP stand? So we looked at TCP/IP version, which is called mobile IP, just before we started doing the presentation, right? So before the end of mid-sem, we looked at mobile IP. Where do you think it will fall? Anybody remembers mobile IP now? I think it's time for an assignment now. If I can give an assignment on mobile IP, then everybody will again. So what is mobile IP? Let me recap. What is the mobility part in the IP? so let's start with very simple. What is IP? Okay, what's IP? Internet Protocol. Okay, but what does it do? Right. So it gives unique address to every node, and then the protocol is about how to send one message from one IP node to another IP node. And now in this protocol, everybody is static. Okay, so there is no mobility. If you introduce mobility now, what's going to happen is your IP address will change. Because IP address are geographically assigned. An IP address in Delhi would be different from IP address in Calcutta. So now you move from Delhi to Calcutta, your IP will change, but you still want all your packets to come. So that's where you need mobile IP. That's right. IP address, right? So for example, this is the example. You are connected to one Wi-Fi access point. No matter where you sit in the room, right? You will still, you are mobile, but your IP address will stay constant. And there is no need for mobile IP.
Another example is this: suppose we are in the cloud or in the lab, wherever we are or in the lobby, the IP address will be fixed.
Yes. Yes. So that's not mobile IP. Mobile IP is something where your IP address need to be changed. So for example, if you're traveling from here to Calcutta, we keep changing IP addresses, and so it will fall here, right?
But from Calcutta, we cannot access base station in Delhi, so that will also
right. Right. So we assume that there are some basic static access points everywhere, and your node will connect to them as you go. And even if you directly go from here to there, there will be some node which will act as a base station in Calcutta region for you. So that's where. So this is where the mobile IP will come. So the reason for emphasizing this is what we will look at from today onwards is more complex than this one. It's not as easy as this one, right? So in fact, the protocol that I will show you today or in the next classes, it's not even yet fully implemented, and so the protocol is there, but you will not find a real deployment where actually it is being used. So it's very new, it's cutting edge. Anybody has learned about MANET Routing in the previous courses somewhere, anywhere? Okay. So I can go in deep. So we slowly go into this, because if I just introduce you the protocol, you will not understand what is the motivation of coming for the protocol. So what objectives of this lectures are, I will introduce or refresh your concepts of routing, because a lot of times I find that even though you have taken the networks course, you haven't really understood the concepts of routing. So we'll quickly go through them. Then we will introduce the challenges and why we need MANET routing. So basic principle of this new routing. These are the two standard protocols, a routing algorithm. So what are the routing algorithms for the standard IP? Anybody remembers the name of the routing protocols in standard IP? No. Okay, the standard routing in any graph, how do you send when you want to send packet from one node to another node? Link state. And what is the second one? Distance vector. Right. So there are only two algorithms if you categorize: link state and distance vector. Any routing algorithm, there is variation of these. What is the difference between link state and distance vector? Or what is a link state? Since you first came up with link state, how can you, I don't want all the steps, but the basic concept of principle of link state. This is always confusing, because every time you see these terms, you always, it's like left and right. Right? Sometimes you don't understand what is left and what is right. So this is left and right of routing, link state and distance vector. So what is our principal difference in the standard grade question or any MS level question? What is the difference between link state and distance vector? Think about it. you can, those of you are on the internet, you search the internet if you want to, whatever you want to do. But think about it and tell me, what is the difference between link state and distance vector? Since there are two algorithms, and so who came up with distance vector and who came up with link state? So let's talk about the history now. You know the names of the scientists who came up with these two algorithms. You should at least know distance vector. So it's Dijkstra, right? And this one, there are two people who simultaneously came up in different corners of the world with the same algorithm, right? These two independently came up with the algorithm, and then when they saw in their papers that is actually the same algorithm, but the credit now is given to both the people because they independently came up and invented the algorithm. This is given to just one person who is really famous. That's one. Okay, so that is one difference between these two. I want a technical difference now. If you remember the steps of that distance vector, link state, you can then tell me. Okay, so let me give you a hint. What is the piece, what is the message that two node exchange in this protocol and in this protocol? So there is some message that they keep on exchanging, right? What is that information for this protocol and what is that information for this protocol? Right. So there is something. So what does distance vector exchange? A vector which contains some distance to neighbors or let's say okay. Oh no, I will see. Okay, so this is for distance vector. What could be the message? What is the message for link state? Right. But what is the table contain? It's also a vector, but it's something different.
It will contain the shortest path from that node to all the nodes.
So this all you say here, right? So link state contains all the neighbors information. Right? Where my neighbors are and so on. Right? So basic principle between these two and differentiation between link state is the way, and this you can just remember for whole lifetime now. And whenever you see routing, you will just remember this. Link state, every node has the entire information of the whole network. Right? So in link state, every node knows what is the topology of the whole network. In distance vector, it only knows the next hop distance. Right? So it knows that node number B is from hop count 4 from me, or 3 from me, or 2 from me. Right? So it doesn't know the whole network. It just knows that if I want to send the packet, let's say this is A, this is B, and this is D, the A knows that D is 2 hops away, and I have to go through B. Right? So this is finally it will come, and that is the distance vector. Right? So it doesn't know if there is E here, and so on. Right? So it doesn't know all the nodes, how they are connecting. In link state, every node knows the whole network. Okay? So that is one big difference. So in link state, there is more information. Right? In distance vector, there is less information. So what is the advantage of link state and distance vector then? Or disadvantages? Right. So this will take some time. Like distance vector, you see, you have to do lots of iterations. You have to exchange so many messages, and finally you come to know the route. Right. Link state, you don't need to exchange. Once you know the whole topology, you can find out all the routes, and you don't have to wait. So these two are the standard routing algorithms. Even in MANET, when everybody is mobile, we will find versions of these to optimize. So we don't want to keep on exchanging messages all the time. So we'll see how we will modify this, and we have two algorithms. And just like there are two algorithms for this distance vector and link state, there are two algorithms for MANET, AOTV and OLSR, standard one. There is no third algorithm. Anything is then combination of these two or something in between. Then we'll see all the issues related with this and the routing protocols. And so the routing algorithms might look very simple to you, but instead that the problem was very hard, and it took a lot of research to come up with the solution. So, and then once you understand the solution, you also understand the complexity. So we go slowly. Where is the routing happening in OSI layers? Where do you do the routing in OSI? Network layer, which is layer number 3, right? So we'll see how we can do it at layer 2, and then we'll see why it is not a good idea and we need layer 3. But then it's possible to even do it layer 2. We will, since you have all forgotten what distance vector and link state is, we will quickly go through and remind you what these two algorithms are. Because otherwise you cannot understand these two. You don't know this. Then I will show you a model of mobile ad hoc networks, and we will always see graphs. So you will see all the algorithms are graph algorithms. And we will go in detail for these two protocols. So far, as I was describing different categories of 0, 1, 2, you see this is the infrastructure mode, a very simple mode, where there is one access point which is acting like a master, and then you have all the slave nodes here around you. This is the mobile node. You don't see an access point, you don't see a square. Everybody is round, and they can move around. Right? So this is what the ad hoc mode is. In fact, most of your wireless cards in the laptop, they can go into this ad hoc mode. You can actually put them in the ad hoc mode, and then you don't need a base station. And any other computer can connect to your machine. So, depending on which protocol you are using, there is different terminology. So 802.11, which is the Wi-Fi, we call it a BSS, Basic Service Set. If you are using Bluetooth, it will call it a piconet. So this is a BSS or a piconet. Then in this, there is no need for routing on layer 3. Right? You don't need routing. If you want to send a message from here to here, you just send it to base station, and base station will do it. You don't need a very complex routing table. But here, if you want to send the data to here, you don't know how to send it. You can just send it to everybody, but that will just create too many packets. Okay? So this is the complex part. So how will you do layer 2 routing? If this is a question. You assume the basic service set, Wi-Fi, master and slaves. How would you do the routing? Think about this. If you want to read this, yeah, go ahead. But then you need to explain it to me. How would you find the solution? See, this might seem a little technical, so that's what I'm saying. If you just think in the terms that you know, it will be easy for you to understand and then to explain in your words. So what I'm saying is I don't have distance vector or link state protocol running on my machine. Right? So there is no routing algorithm running. I just have 2 laptops or 3 laptops. 2 is not sufficient. I have 3 laptops. I want to send packet from one laptop to another laptop. I have a base station. How do I do that? How do your machine will do it? Right, but what will you send? Now let's go in details.
So we need to send it to which machine do we want to send?
Right. So there is a destination IP address, right? first find out a destination IP address. Now what do we do?
So you need to check that if there is nothing else sending to base station. No one else is sending to base station for the
Right. So you execute the CSNA protocol and so on. You send this packet to the base station. But before that, how do you decide whether you should send it to the base station or not?
Because you don't have any logic. We are going into a second layer.
Right.
We don't have any logic.
Okay.
We don't know where is the
Right.
but we know where is base station.
Right. So sending to base station, that will also not happen from magic. Right? So base station will also have an IP address. Right? So you have a source IP. This is what you will have. You have a destination IP address with the packet, and you know base station's IP address. Now you give it to layer 2. Now layer 2 will say, I don't understand IP address. Right? Layer 2 doesn't know any IP address. So what will layer 2 do now? What do we have to do on my laptop and give it to layer 2? So what is the IP address? What is the address of layer 2? What is that address called? MAC address. Right? So you convert base IP to base MAC address. Right? And this is available. This is a cached information from ARP protocol. Right? So now you have gone into, you have solved your problem and converted from layer 3 to layer 2. Right? So everything is in layer 2. You put this MAC address onto the frame, give it to layer 2. Layer 2 will deliver it to the base station. Okay? So that packet comes there. Now what's happening? So if you imagine, this is the frame and this is the IP packet embedded in between. Right? So this is how the encapsulation is happening. So all the MAC addresses are here, all the IP addresses are put into the IP packet. Right? So it's residing inside. Base station gets this, it will take out the frame address, it will look at the packet. It sees the source IP and destination IP. It sees that the destination IP is not the IP of its own. So it sees it has to give this packet to somebody else. Now what will base station do?
Find what the corresponding
MAC address of
destination.
destination, right? So it converts this to destination MAC. Right? So it gets the MAC address. It will form a new frame, frame dash, and it will put all this information there, get that IP packet, put it here, and this IP packet, this frame will be broadcasted using CSNA protocol, and the destination will pick this up frame and it will get the packet. Now you see, I have sent the packet from source to destination, which are not directly connected to each other. Right? So this is the source, this is the destination, and I went through something called B. Right? So this means actually I have done routing, because they are not directly connected to each other. So that means packet actually did routing, but I did not execute link state protocol and I did not use the distance vector protocol. So without using any routing algorithm, we finished the routing protocol. Right? So this is what layer 2 routing is. And this is what is done in your home network. So if you have 2 laptops at your home and you want to send data from one laptop to another laptop, we do layer 2 routing. Or within here also, if you want to send data from your machine to the server, like Moodle server or any other server, everything is happening at layer 2. Right? Because we are all connected in the same subnet. Right? If you are in the same IP subnet, then you don't need the complex routing protocol. So all these Ethernet bridges, A2 access point, they are doing routing. Your DSL router, your cable modem, everything is doing routing within the subnet without using any of the complex protocol. right? But this will not work if you go outside the subnet. So before going there, this is an example of the same thing I described with all the IP addresses. So one thing is, please be familiar with all these notations, because in the exams also I might ask you some questions and you will follow these notations. Right? So I will not describe it in words. I will just put the numbers like IP address subnet, and please don't ask me at the time of the examination what is this means and what does that mean. Right? So local IP, you should be able to now, since you are an IT student, you should be able to read the IP address and tell me about it. So local IP is this, subnet mask is this. So how many nodes are there in this subnet? 255. Why not 256?
Because the last one is reserved.
Is reserved, right? So it's reserved for the broadcast. So if I say 10.0.1.255, this address by definition of the IP protocol is reserved for broadcast. That means if you send the packet to this, it will be flooded to all the nodes. So if you try to send your packet, so if you have 192.168.1.10, no, we have 4.10, right? And if you try to send the packet to 255, 4.255, this is all same. The access point will block that packet, right? Because the access point is not allowed. What we have configured is don't send broadcast, because everybody just get packets, so many packets, right? Okay. So this is the mask, subnet mask, right? So if you mask it in binary, you can find out how many nodes are there, right? So local networks will typically, if you want to just say, you will say 10.0.1.x.
So,
Yes.
in triple IT, do we have a blockage for like flooding someone else's IP address?
Yes. So the switches, so there is different layers, right? So this is an access point. What we say is a layer 2 device, right? Then there are switches that you see, which are sitting somewhere in between, outside the labs, all the computer labs. You see there is a room and there are all the switches. Again, these are layer 2 devices. So if you, let's say some of you might go join Cisco and those companies, you will hear this term run. So these are all layer 2 devices. Okay. So there is something called a layer 3 device. So this will do intelligent routing. So this actually execute. Right? At layer 2, if you send something to 255, it will block it. Because it will just take, it has to send it to all the layer 2 devices, to all the access points and everywhere. Right? So it will just create too many packets. So we block it. So this is the destination IP 1.9. So you see, you can find out what is the network address of this IP, which is 10.0.1.x. So this is same as this one, right? You need to focus here and here. So both of them are in the same subnet, or in the same network, and then you know that you don't need to do layer 3 routing. You can do it with layer 2. And the way it will be done is through access point. Okay? So you have to get the actual MAC addresses, and for that you will use the ARP protocol. And then with the MAC address, you can, as I was describing earlier, send the frame to the destination. So ARP is used to convert from layer 3 to layer 2, and once you convert it to layer 2, everything is in layer 2. So any questions about?
Not this one. The previous continuation of the previous thing. What did block the P2P services which we have for the, like, we can't have any P2P services for our triple ITD students.
No, you can, unless it is not broadcast.
So, like a huge file, understand, like if a huge file is being transferred between two peers,
Yes.
then won't that be blocked according to that flooding?
No. So flooding means you are sending one packet to all the laptops.
So like, I didn't mean actually flooding. So I was actually, it is a focused flooding like a specific IP address. So like I'm sending packets to a focused IP address and blocks.
So we are overloading the terms like flooding. So there is a standard term which is called broadcast. So flooding is actually not there. Right? Flooding means something different. Let's forget flooding. When you say broadcast, that means send one packet every destination in the network. Okay, so that is broadcast. Flooding is a different thing, and in IP there is really not a meaning of flooding. In protocol we say flooding, but which is a different. But we do not allow broadcast.
Okay, so.
But in UAS, it's not flooding. You just send too many packets to one node, which is fine.
So that is allowed. So that may cause a denial of service to anyone, any IP address.
No, that anyway will happen. If you're downloading a movie, right, you will get too many packets. So that way. So we can see how many packets you are sending, and we can keep a limit on it. So what do we do is, if you now, I'm going into the details, if you see a layer 2 switch, I can tell that just send packets at these many rates. I can say just use 2 Gbps. Don't go more than 2 Gbps. So I can say for faculty it could be 4 Gbps, for students it's 2 Gbps and so on. So the switch is now intelligent. If it sees too many data coming from you, it will drop it. And then laptop will become slower now. So basically you are looking at 2 Gbps connection. So this is how we will ensure the quality.
So this is not presently actually implemented in triple ID.
No, not yet, because our networks are fast enough. Right? So the bottleneck will typically happen when you send it outside. So within it's fine, right? You send packet from your friend's laptop to here, we don't pay.
Yeah.
We pay when we send it outside and get from outside. And that is expensive. So we have seen this. Now we will see the need of layer 3 when this is not sufficient enough. Right? The world is not so simple, right? We cannot just keep on using layer 2 routing. There is a case where we need to use layer 3. So because nodes may not be connected by layer 2 or the node. So for example, if you are accessing your email, you will connect to Gmail and then that is outside. At that point you will need layer 3 routing. And what basically it means is it nodes mathematically. If the nodes are in different IP subnets, so if you look for Google's IP address, it is something, right, 144 or something, and your IP address is, right now it is 192, but it's a local IP address. What is the IP address is typically the IP address of IIITD, 180 something, right? So these two are different IP addresses, and so you need layer 3 routing. And that means another way to look at this is you're not in the same radio link, which is fine. It's the same thing. So the example is, this is 10013. So anybody knows what this symbol is?
IP at the receiving end, IP at the.
So what does that mean? What is this device?
That's a router.
It's a router. If you see two interfaces and two interfaces with different IP addresses, not in the same subnet, which means it's a routing device. It will get packet from one interface and send it to another. This is a node. So you see, this interface of the node and this interface of the router, if you look at their IP addresses, what does it tell you? So the IP address of interface of this node is this 1.3. IP address of this router on the left hand side is 1.1. What does that mean?
That is the reason.
Same subnet.
Like in my house, when I access the router from my PC, it will a different IP address. Okay, when I attempt to download multiple files from like some site like the files or the files, then it will say that this IP is already downloaded.
Right.
Is my router liking on outside mix?
Yes, yes. Right. So and the reason it is called router is because it has multiple IP addresses. Right? And so this and this is in the same subnet. Okay? Now if you look at these two addresses, 3.3 and 3.6, again they are in the same subnet. And then if you see 461, 469, they are also in the same subnet. So you have 1, 2, 3 subnets. Okay? And that makes it challenging now. How to send packet if I want to send it from 1.3 to 6.9, 4.6.9. So immediately this node will see that it's not in the same subnet. So I cannot send it at layer 2. I have to use a router. Right? So it will land up in the router. It has to again find out using some routing algorithm that it has to send it to this interface, and this will find out that it goes here and so on. Right? And all of this is very complex. And you see this algorithm, distance vector link state. Actually, in reality, what happens is when Tata and Reliance they configure their routers, big routers, they don't even use these algorithms. They just manually feed in everything. Right? These algorithms are very good in theory, but this is the difference between theory and practice now. System admins, they don't even trust these routing algorithms because it's a very complex network. You understand? There is optical fibers, there are fibers going through the sea from one nation to another nation. It's very complex and there is too much business involved in it. Right? They're charging you so much. So they will just manually tell that to this node that if you want to send it to this, send it to this router. That's it. So that is what, do you know the term for that? So there is a very standard term for the machine where you send the packet by default. You must have configured it also in your IP program. Gateway. Okay. So gateway is a very nice way. You just by default put the routing without executing the routing algorithm. You just say the gateway is this, that means no matter where you want to send packets, just give it to this node. And similarly, the gateway for this node could be this, and the gateway for this node could be this. Right? And the packet will come. So this is manual routing.
Network address translation.
So network address translation is a completely different concept. So we will not go in detail, but it has nothing to do with address translations. Okay. So as I was saying, most of the routers just manually do it. So we'll go into mathematics here because we want to put this problem into mathematics so that we can solve it. So there are two fundamental steps in routing. One is forwarding the packets to the next hop, which means from an input interface to an output interface. Right? So you have to forward the packet. Now, and second thing is you have to find out how to forward packets. You have to find out a table which you can use for translation. A simplest table is one like this, which is in your computer. Right? So all your computers are using a very simple table. Right? Or in your case it's 4.1. It's a very simple routing table. And it basically means start, 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 start. Right? If you want to send any packet to anything, just send it to this one. 4.1, which is the gateway. Right? That's the simplest routing table. But you can imagine that for the whole network of the internet, you will need a more complex one. You can't give it to just one person. Right? Because that person then has to send it to everything. So let's see this problem. So your IP is 1.4.10. So what will happen? It should work, right? Will not work. Why?
0.0.0.0 means that's an international 192 IP.
Right.
And 192 is not allowed from international.
Right. So let's start. So that is true. It will have some special meaning. But even if we remove the special meaning, what will happen in this case? Your computer. Yes. But yeah, you can think about this. What will happen?
If the static is done, it means that you have this static IP from it's the global static IP. And anyone can send packets.
That is That is really different. Yes, yes. So what it means, how this network has got everything in it, right? All the nodes. 255 into 255, all these nodes, right? So that means you are forming just one network of all the nodes. Right? One single big network, but it's not there. So if you try to send now any packet, it will fail. It will not reach the destination.
Because even we have that second option. If all the routers are configured like this.
Okay, so you're saying all the routers.
Like in triple ID, or we configure all the routers.
No, we can't go just triple ID. We have to be in the entire world.
So then after that we will gateway to the router. In the inside triple ID, you can all the ID. You have a
Yes, yes. So it can be, you don't have to go to 000. Someday, where everything becomes one subnet. Right. So you can do that, but we don't do that because, so we say something called the VLAN. It's a Cisco's term. If you go to Cisco Norton, they will use these terms. The reason we don't do it because we want to separate these subnets. So faculty is different from students. So if you want to implement some policy, for faculty we can do that. Some policy for students we can do that and so on. Right? For servers there is different policy. We put them in the same different subnet. And then we can disconnect one group from the internet or anything. Okay? And also the packet from one within your subnet will just go to your subnet. It will not go to the faculty. And similarly faculty's email packet will not come to the student. Right? So you cannot actually snoop onto the packets that other people are sending. So for security reasons and efficiency we don't do it, but we can do it. Yes, we can do that. Okay, so coming back to this, so you have to forward packets and you have to find the route, the table to do it. The first part is very easy, right? Forwarding is very easy. Just take the packet, put it into a different buffer, and that means it is forwarded. Right? So that is easy. But this is hard. Where to send the packet or which interface to select to send packets, that's the hard, that's the intelligence. And we need to find out an algorithm that can do all these things. It should reach the destination. First of all, if you remove this, then the problem becomes trivial, right? You just send it to anybody. So you have a correctness criteria. So it should reach the destination. Not only destination by a very long route, but you should reach it as quickly as possible. So you have to minimize the number of hops you want to send the packets across. Minimize delay, that means you want to send it as soon as possible. Minimize packet loss. So if some network link is dropping the packets, you should then, the routing algorithm should understand this and select a different route. By the way, this is all interconnected. For example, if a network link is dropping the packets, your delay will increase because you have to retransmit. So it's not independent, these are all interlinked. This is something we will not consider. This is for the industry, minimize cost. Because every link has a cost, depending upon which internet service provider you are using. So you can even consider that. So the routing algorithm now becomes far more complex. You have to take into consideration all of these things. So if you want to solve it, we'll simplify things. We'll just look at a graph, first of all. Right? It's a planar graph. That means all the edges are coming and not crossing each other. Right? And then every edge will get some weight. Right? So that will find out the number of hops and also minimize all of these things. So this is how we mathematically find the problem. So let's take a break of 5 minutes. I don't want to overload you. Now if you want to look at how the routing can be done. So routing is an algorithm. It's a program that will continuously run. Now the question is, where would you run it continuously and who will make the decision? Depending upon the location of this decision point, you can have different algorithms. So what will be the simplest, if you don't look at the slide, it will confuse you. So if I want to tell you, this is my network, there are 10 nodes, 100 nodes in it, and I want to do routing, how will you find out? Manual, the brute force attack. Right, so that is one way. But let's say I don't want to send it, I want to do routing. I don't want to send it to everybody. But I still want to satisfy the two properties of routing. It should forward the packet and it should have a table. Now given these 10 nodes, what will I do? By brute force. How will I do the routing?
Just keep a table of this router, keep one address there. So each of the IP address keep one entry for the next hop.
Right. So what he's saying is, I as a central person, I'm looking at entire network. Right. So for example, all of these laptops are sitting here, and I want to find out the routing algorithm for each laptop. I can actually measure the distance. Right. As a third person, between all of the laptops, find out the routing table, give that table to every laptop. Right. So it's a centralized algorithm. A central authority is looking at the whole network, do the computation and find out the routes. This is what is doing in the source routing. Right? So at the source, you have the entire topology of the network. You find out all the routes, and then when you send the packet, you actually mention that this packet should go to A, then B to C to D. Right? The source can do that. And this is called the source routing algorithm. And link state algorithm is an example of source routing, because every node has the knowledge of the entire network. This is one. Second is hop by hop routing. And this is not centralized now. The source doesn't know the whole network. It just knows that if I want to send the packet to the node to the destination, I should forward it to this hop, this node. And this will go on. Right, so the next node will again get the packet, see the destination and give it to somebody, and so on. And it will go hop by hop to the destination. So in source routing, source finds out the entire route and send the packet. Packet will go to the same route all the way to the destination. In here, source doesn't know the entire route. It just knows which is the next hop, and it's called hop by hop route. And then there is, so this is typically used in IP. Right? This is supporting IP protocol, but it is not used, and you can imagine why it is not used. Okay. Here it is used in routing in the IP protocol. And then there is a virtual circuit routing. So it's used in ATM, asynchronous transfer mode. It's not anytime machine, right? Teller machine. So what is ATM? What is virtual circuit? Which one is?
Like DSL, APN, and they use APN.
Right. So what is it? So you're getting there. What is the difference between IP and virtual?
They have some values. There are two values according to which the routing sector can be.
So let's come to the telephone network. What is happening? What is the difference between telephone network and internet?
Sir, in this internet, the path is determined dynamically.
Right. So in telephone, you fix the path. Right. When I call a number, the entire path is established. Right. And I will keep sending packets on the same path. When I hang up the phone, I will disconnect the path. In IP, that's not the case. Every packet is different, and every packet can go in a different route and come to the destination, and there we assemble everything with the sequencer. Right, so this is typically a telephone network.
Basically, it is designed and such a way to basically emulate a circuit system over a packet system.
Yes, that's right. So it's a packet switch network, but then you establish like a circuit, like a telephone dot, entire path, and you send the data over that. This was proposed in a protocol called ATM, and it was very famous. People thought it would be very good because they want to provide quality of service. Once you establish a call, like in telephone, you can provide quality of service. But that was not the case. The internet finally selected these two, and this is prevalently used. There's one version of this thing is still in use. It's called VPN. So VPN technology, virtual private networks, still use something which is like virtual circuit routing. So when you establish a VPN connection, For example, let's say I am a Tata employee and I want to connect to my mail server in Tata, TCS. I can use VPN. What will that assure me is that my packet will never go to Reliance. Right? So there are some things that is done by industry or VPN and they fix a path and you send all the data through that path. So overall there are three algorithms. Source, that the source decides the entire route and that route is followed. Then you can change it from packet to packet. Right? So the difference between this and this is you can change the route from one packet to another packet, but you have to mention the entire path. This is the easiest case where you just take a packet and give it to the next hop, and you don't know how that packet will go to the final destination. And this is used in IP, and this is called virtual circuit routing, where you establish a virtual circuit. It's not an actual telephone circuit over a packet or datagram display. So these are the three algorithms. Yes. So this is distance vector and this is link state. If you want to look at the standard algorithms and classify them now, this will be the link state algorithm and this will be the distance vector. So we saw what is the routing algorithm we can come up with. Now the table. So depending upon which routing you are using, source, hop by hop or virtual circuit, routing table will change. Your routing table will be different. So for source routing, the routing table is specified the route to the destination to be specified in the whole packet. So you go to the routing table, you find out all the next hop, 1, 2, 3, 4, all the way to the destination. You take that and you put it in the packet. Hop by hop just tells you the table to find out the next hop. Right? So it will say if you want to send it to the destination D, give it to C. That's it. So routing table is simple. In this case, the routing table is small. In this case, the routing table is bigger because you have the entire network's routes. This is for virtual circuit. Again, it will be again simple because you just give it to this circuit. If the circuit has an ID, you will just give the IDs of those circuits and you will send it. Now, a distributed algorithm is required to build routing table in the internet because in the internet is not governed by one single point. As a single entity, I cannot get the whole picture of the internet. It's never possible. So you cannot have a centralized algorithm. It has to be distributed. That means every node in the network will run some algorithm, keep exchanging the messages, and finally I can construct a routing table. So both these algorithms are distributed. But as you see, the decisions are different and the tables are different.
How is comparatively more smarter than source routing in case there is some congestion? So in case of hop by hop, it can easily change the path and send it to the other, send it to another node which will further transmit it to the destination. While in this source routing, this cannot happen. If there is some congestion in that path, what will happen then? It will be discarded or the packet will
In both the algorithms, if there is a congestion, what will happen is, so whenever congestion is detected on a link, what does that translate to the algorithm? You change the weight of that link. Typically, you will make it higher. Right? So the cost of sending packet over that is higher. And now that information about the change of the link cost has to propagate in the entire network. And it will happen in both the algorithms.
But once the packet is sent from one
Right.
source,
Okay.
and all the paths
That's right.
after that congestion happens, they are
Right.
okay.
That's a good point. Right? So in this algorithm, the packet has to incur that cost. In the next algorithm, dynamically in between, if the routes are changed, you will go to a different. So that is a good point. So a distance of each link is the network that has to be minimized. So it's an optimization problem. Take this problem of network and put it into mathematical optimization problem. We want to minimize distance of the route for the network. Each link we say has a distance of 1 to So if you just want to minimize the hop counts, and as you know, you just put every link as cost 1. And that will just minimize the number of hops. And that will give you an algorithm that minimizes the total distance from source to destination. The routing table at each node specifies the next hop for each destination. It has to do it for each destination. You just can't tell, okay, this is the network and then only for these half of the nodes I have the routing. It has to do it for each destination and it should specify the distance to that destination. The neighbors exchange some information. You cannot, see the routing has to happen. Right? So what I'm saying is this is A here, this is D here, and there are nodes in between. And since I don't know the path from A to D cannot exchange any messages directly. Because like this is now a chicken egg problem. I don't have routing, so how do I send the packet to the final node? Right? So only thing that can happen is neighbors can exchange it. So if you come up with an algorithm that uses routing, it's not a valid algorithm. You have to find out an algorithm to find out the routes. So is this point clear or? So what I'm saying is, this algorithm can have nodes just talk to each other in the neighborhood, directly connect, there too. A cannot directly talk to D. If I come up with a routing algorithm, when I say A will send the packet to D, and A and D are not neighbors, that is not possible. Because if you want to send the packet directly from A to D, you should have routing in place, but that's what we are finding out. Right? The routing is something that we need to find out. So that's only neighbors can exchange some information.
So is it like some new concept in the network? So suppose I am the new node which enters into the network, then I'll ask all my neighbors to send me the information and then I'll use that
Yes.
to route it.
Right. And so the neighbors are also vice versa learning about the new node. Right?
And of course they'll update
They will update, right? So they will give you some information about the network and they will take some information about how you are connected to the whole network.
So is this information transmitted immediately as I come up to the network? Like she updates her table when I enter the network, then she will transmit the information to other nodes. So this will happen instantly or this happens at a certain time when...
Right, so this will happen, the first instant is when it should happen immediately. Right? So you switch on the router, it will immediately try to find out neighbors. Because that's the job of the router. And update the information. And after that, regular. Right? So there will be some period after which you can configure this thing. But the first thing should happen immediately, as soon as possible.
And that period will be configured by her, not by me.
So that's the period that the whole network described as a protocol. Right? So just like IP has a timeout, TCP has a timeout and so on, how often to send is something that the protocol says. You cannot send faster and slower. Right? Otherwise there will be stabilization issues. So we will not go into those problems. But there are far more complex problems. The route will have a circle and so on. Next is distance vector, and I'm going to stop at this point because I want you to revise here because there's no point going into detail about this again. Please revise the distance vector and link state before coming so that when I talk about this it's very clear. And then we'll see the AODB and DSR. So let's stop.